Hey everyone, Professor Baldwin here, and today we're being asked to simplify this expression, and notice we have two rational expressions that we need to add together. Remember, adding rational expressions is the same as adding any other kind of fraction. You need a common denominator. And when we're finding our common denominator, first we want to see if we can factor anything. Here we can't. So we're going to try to find that least common denominator between these two. Since nothing can be factored, the least common denominator is going to be a product of the two given denominators, n minus 1 times n plus 1. So now we need to rewrite each of these terms so that they have that denominator, n minus 1 times n plus 1. So looking at the very first rational expression, the denominator was n minus 1, so we had to multiply by n plus 1 in the numerator and the denominator. So our numerator becomes 5 times n plus 1. Now, the second term. We have to multiply by n minus 1 to get that common denominator, so multiply the numerator by n minus 1 as well. Now, before we can continue on and combine these, we need to get rid of those parentheses and distribute. So the first term, let's distribute the 5 through, and we have 5n plus 5 over that denominator, n minus 1 times n plus 1. And the second, we have a numerator of n squared minus n. And our denominator is the same, n minus 1 times n plus 1. Now we can actually combine the numerators. So they have a common denominator, so we'll keep that common denominator of n minus 1 times n plus 1. And our numerator, we have 5n plus 5 from the first rational expression, and we're adding n squared. And we're adding a negative n, so we're still just subtracting the n. Now we want to simplify that numerator, combining any like terms and putting it in the appropriate order, so with descending exponents. So we'll start with the n squared. This is our only n squared. And then we want to look at all the terms that have just an n, so 5n minus n. That becomes a positive 4n. And then our constant is just a positive 5. And our denominator is n minus 1 times n plus 1. Now, before we can claim that we're done, we need to try to factor that numerator. And can we factor n squared plus 4n plus 5? Well, what are two numbers that multiply to 5 and add to 4? The only two numbers that multiply to 5 would be 1 and 5, or 5 and 1. And there's no situation where those would add together and give us 4. So it can't be factored. And since we can't factor that numerator, our final factored form has a polynomial in the numerator. That's okay if it can't be factored.